Hello, welcome to session related to problem solving. In fact, the module called as problem solving. So, for me, it is a favorite one. It is because it is often neglected, and as engineers, we have to solve problems. As engineers, we have to solve problems. Maybe other engineers studies something about the problem solving. I don't know exactly what they are studying, but they may study something about problem solving. But unfortunately, in computer science, it is often neglected. It is often neglected. We concentrate on only programming, we concentrate on only studying theoretical subjects, and we concentrate on programming. We never concentrate on this problem solving. But engineering is all about problem solving. Without studying problem solving, what is the purpose of doing the engineering? I don't understand. So people start thinking that if we are able to do few programs, then it's fine. It's not the case. It's not the case. You have to learn to solve the problems. What is the use of learning about syntax and semantics if you can't solve the problem? For what purpose you are going to use? Definitely you require problem solving skills. You should be able to learn problem solving, and that you can do only if you practice. You can solve the problems only if you practice. You need practice. It's something like all the skills, learning to walk or learning the bicycle, etc. So all these require practice. So in fact, you require continuous practice. If you don't do something for over a period of time, you may not be able to say visualize or do that skill again. Do that skill again. So you need to practice also. It is continuous. But definitely everybody can learn the skill. That is the advantage. Everybody can learn the skill. You can learn the skill, I can learn the skill. Computer science people can learn the skill, this problem solving skill. Electrical people, civil people, they also can learn problem solving. If they learn problem solving related to computer science, then they can easily learn the programming. In fact, in good olden days, when we were in B.Tech, we were not taught programming. Even in university college, some university colleges, it is believed that we should not teach programming. We should not teach programming. But nevertheless, programming is also essential. I am not underestimating it. Programming is also essential. But prerequisite for it is problem solving. Prerequisite for it is problem solving. Programming is essential because that's how you demonstrate your skill to the world. You just know the problem solving skill, and if you don't know programming, then it may be of little use. It may be of little use until you know something about programming. Unless you don't know a programming language, you cannot represent the solution in a way which machine understands. So to represent the solution in a way which machine understands, you require programming. But prerequisite for it is problem solving. So we will concentrate on problem solving. The first topic is, what is a problem? What is a problem actually? So a problem is a situation regarded as unwelcome, or maybe harmful also, and needing to be dealt with, So a matter or situation regarded as unwelcome. So you may be in some situation. If it is comfortable to you, you can continue in that situation. But if it is not comfortable to you, or if it is harmful to you, you want to go to some other situation. So there are two states here or situations here. One is initial situation, the other one is goal situation. So problem solving is nothing but going from the initial situation to the goal situation. So initial, and want to go to the goal situation. So you want to go from this initial situation to the goal situation. So this is nothing but problem solving. Problem solving. So we solve problems. In fact, every common man solves problems in day-to-day life. It is not new to us. Only thing is you want to make the computer solve it, so you need different set of skills. You need different way of thinking. You need different way of thinking. You need different way of thinking. The problems are computable if an algorithm exists. Algorithm is nothing but a sequence of steps to be followed for solving the problem. A sequence of steps to be followed for solving the problem. Later we'll study in detail about the algorithm, what are the steps, how to represent those steps, etc. etc. But for the time being, an algorithm is nothing but a sequence of steps to be followed for solving a problem. And we are more interested in solving the problem is using computers or computational problems. And sometimes these computational problems can be solved without using a computer also. That may be a surprise for you, but you can solve problems without using computers also. In fact, that's how the problem solving actually started. So there were what are called as theoretical computers, or more technical term is Turing machine. Turing machine is a theoretical computer that was used to solve many problems. Even nowadays it can be used. So if you are more interested, study about Turing machine. You will study in maybe in second year or third year, subject based on theoretical computer science. But if you are more interested, you can study about Turing machine. In fact, you try to know about the Turing machine. You try to know about the person called as Turing. He did a lot of contribution to computer science. So problems can be solved, computational problems can be solved without using computers also. As a programmer, you may be interested in solving the problem using computers. So definitely, because you want to run it and make the machine do the computations, so definitely you want to program. So as a programmer, you want to solve the problem in such a way that computer understands. You want to provide the solution to the computer in such a way that it understands and it executes it for you. For you. There are few principles related to the programming which are important that we are going to discuss. Principles. So principles of programming. Few important principles. The first one is the principle of abstraction or abstraction. Abstraction is taking the essential characteristics for the time being and neglecting the other things. Taking the essential characteristics for the time being and neglecting the other things. What is that taking the essential characteristics for the time being? That means whenever the problem becomes complex, do not take the entire problem as a unit and try to solve it. You have to find what are called as different levels of abstraction, and you should work out each level of abstraction at a time. So you will consider the entire problem after that, but different levels of abstraction are identified, and then the solutions are provided to those different levels of abstraction, and then you are going to combine. So complex problems like computer network, operating system, they are designed using, if you have to write a software for computer network operating system, they are designed using what is called as layered approach, or the main principle is principle of abstraction. We'll take few examples. Suppose you take a ready-made sambar rice packet. So what you are going to do, you are going to purchase it from the market, insert it in the hot water, keep it for 15-20 minutes, and then fine, you can eat it. Of course, it's not recommended because there will be preservatives, but anyhow, you can eat it. So when you are eating this one, so you don't bother about how this rice is grown, how the dal is grown, how much is mixed actually, and how it cooks, how it gets cooked. Okay, all those things you will not be knowing. So that means you are using the principle of abstraction. So that means you are concentrating on how to remove that pouch, how to place it in the hot water, and how much time it has to be placed in the hot water. That's all. That means you are at a level of abstraction. At other level, the say the person who is packing, he should know how much rice has to be put, how much dal has to be put, how much other ingredients are to be put. So how to seal that pack, so that it will not get damaged. So all those things he should know. But he also never thinks about how it cooks, etc. And if you go to the farmer, so farmer knows how to grow the rice or how to grow this dal. So various ingredients. So you have different levels of abstraction. Similarly, suppose you want to drive a motor vehicle. So what you are going to do, you have to just put the key. Just put the key, turn the engine on. That means you are moving the key, turn the engine on, and then so you are going to start it. You are going to start it with a button if that is available, and then you are going to raise the accelerator and you are going to move forward. But you never bother about how the engine works, how the ignition works, how it is balanced actually, how the two-wheeler is balanced. You will never bother about it. The physics behind it, you never bother about it. So you are using the principle of abstraction, but mechanic need to know about it. So same problem may be viewed by different people in different perspectives. Another example is suppose you have a cat. Now how old woman views it, how this doctor views it. Old woman views it from the perspective of these superstitions, whether it is good symptom or bad symptom. But doctor views it in terms of eyes, lungs, skeleton, etc. So two different perspectives. So depending on the problem you are going to solve, we have to use different perspectives. Different abstractions. So abstraction is the major principle in computer science, and also is the commonly used principle by even the common man. That point please remember. Decomposition is another one. Decomposition is another important one. So whenever you take a problem, the problem will be complex one. So what you will do is you will be dividing that into parts. That means you will be using the technique called as divide and conquer. Using divide and conquer technique, you will be dividing the problem into subproblems, and you will be solving the subproblems first and then combining them to achieve the final solution. So this decomposition and combined integration is very much essential, because whenever you take a complex problem, that complex problem will be divided into parts, and each part will be given to a member of the team. So you have to work in a team. For all complex problems, you have to work in a team. So divide it into sub-problems, give the sub-problem to each team member, let them solve it, and then try to combine it, integrate it. So decomposition is another technique that is also natural to us. Decomposition. Natural to human beings. Mathematical problems are intrinsically computational problems. So usually these mathematical problems are easy to solve. Because there exists a procedure for it, or algorithm for it, So there will be a procedure. So according to that procedure, if you know the procedure, if you can use the procedure correctly, then you will be able to solve the problem. But there will be different kind of problems. There will be different constraints. Maybe we will consider few such problems. We are not going to solve them. But we are going to consider them, and we are going to understand the logic behind the problems or problem solving. How do you measure the happiness of a person? Somebody asks you, how do you measure the happiness of a person? How do you measure the happiness of a person? How do you measure the happiness of a person? Using a computer program. Using a computer program. So first, it may not be clear to you. You can say you cannot solve it. Cannot solve it. But you have to make careful observations. Now, what happens? What happens when a person smiles? Whenever he is happy, what happens? Many things can happen. One is whenever he smiles, that means whenever he's happy, he may smile. So whenever he smiles, maybe his mouth becomes like this, just expands to some extent. Maybe he don't blink. Maybe he don't blink. Maybe he starts talking fast. He starts talking fast. Okay, that means he is confident. He starts talking fast. Little bit. Little bit. Okay. So all those things you have to consider. You have to consider different facial features, your cheeks, etc. And what are the initial values for those things? What are the final values for those things? Based on that one, you can decide whether the person is feeling happy or not. Whether the person is feeling or not. Remember, we are trying to quantify it. The problem is not clearly defined. We are trying to quantify it as a computational problem. We are trying to represent it as a computational problem. And then you are considering different metrics or parameters, and then these different metrics or parameters are measured based on that one, based on the quantities. You are going to tell whether the person is happy or not. So for some problems, you have to do it. The other kind of problem, traveling salesman problem or salesperson problem. The problem is there will be number of cities connected cities. So what the salesman has to do is to start at a particular city. He should go and visit each and every city exactly once. Go and visit each and every city exactly once, and then he has to return back to the initial city. Return back to the initial city. Now, suppose if there are 2 cities, 3 cities, 4 cities, the problem may appear simple. The problem may appear simple because you have to just find out different routes. You have to just find out the different routes and choose the best one among them. But as the number of cities increases, the number of routes increases. And the number of routes increases in an exponential manner. N-1 factorial routes you have to find. So finding N-1 factorial routes and then evaluating them, it's not a simple task. It's a complex task. It puts a lot of burden. Remember, the factorial value increases drastically. There will be an exponential increase. So computer has its own limitations. The amount of value that can be stored. The value that can be stored inside a computer is limited. You cannot store 100-digit number. Of course, there are special techniques, but if you are using a programming language, you cannot store 100-digit number. You cannot store a 100-digit number. So computing factorials or computing the roots, is a difficult task. So certain problems may appear to be simple when you just see it, but because of the limitations of the current computational resources, they may become difficult to solve using computer. Another problem is generation of timetable. Timetable. The timetable is considered as an open problem. Generating the timetable, there is no perfect solution for it. There will be number of constraints. I don't want to take first hour. I don't want to take on Friday, etc., etc. There will be number of things. All those constraints are to be considered. You cannot arrive at the perfect solution. You don't know the perfect solution. In fact, perfect solution, even if you arrive considering the different constraints now, if the constraints change, then it may not be the perfect solution. So you can actually determine the timetable, no problem, but it will be a suboptimal one. It will not be the best one. So that's why it is considered as open problem. So you may have to deal with such problems also. And the last one is halting problem or undecidable problem. That means you cannot decide. You will study more about these undecidable problems in theoretical computer science subject. But halting problem is given the program code on some input, is it possible without running the program to find whether the program will halt for given input or run forever? You have to find whether a program will halt for given input or not. So you may think that it is easy, but you cannot decide. Proof we are not going to get into it. Then if you want to, you can refer to internet. Halting problem. So these are the standard problems. Standard problems in the sense that these are the different type of problems which you have to solve. So these are the references. So in this session, we discussed how or what is the problem, what are the different kinds of problems, what are the importance of problem solving. So these things we discussed. In the next session, again, we are going to discuss about how to solve the problems. So happy problem solving. Best of luck. Thank you.